Excited to be here. Thanks for coming to my talk. Just curious, how many of you went to, were at Jerry's talk like 2 talks ago? Okay, cool. And how many of you have put a RAG pipeline into production? Oh, nice. Way more than I thought. This is awesome. And how many of you have worked on recommender systems or like personalization systems in the past? Nice. Okay, cool. So this is great. So we're going to be talking about components of self-optimizing RAG. It's basically sort of a fancy term for having a feedback loop, right? A little bit more than that, but at the core, that's what it is. What are the knobs you can turn? How to set up that loop, and what are the things you need to assemble and watch out for. So my name is Chang. I'm the CEO and co-founder of LandCB. I've been working on data tools for data science and machine learning for about 2 decades at this point. I was one of the original co-authors of the Pandas library. It was a long time ago. And I spent a bunch of time in big data systems and recommender systems in the past. And I'm now building LandCB, the database for multimodal AI. So I'll tell you a little bit about LandCB later on and how it can be part of this RAG pipeline and be the storage and querying layer for these things. And I'm an engineer by training, but these days I spend about equal time tweeting and coding. And you can go to Ship Talkers to find out your own ratio if you're curious. So I think the reason why I'm really interested in this topic is I think right now there's sort of a gap in RAG, taking RAG from demos into production. And so, probably lots of you have put RAG into production. So I think a lot of you have seen that pain point of, getting to a compelling demo can be pretty quick and easy, but getting that reliably into production is much harder, way harder than sort of you would extrapolate from the effort of that demo. So part of that is retrieval quality, right? It's that 80-20 rule, right? It's like 20% of the effort to get to that like 80% demo, but then how do you get that last 20% so you can get into production? And that usually, I think usually that doesn't take 80% of the time, that takes like 120% of the time. Right? And of course, I think getting RAG into production, as you probably know from your experience, it's not about having that perfect setup right from the beginning, but how to set it up so that you have continuous improvement over time and it just gets better and better. The more you use it and the more you have user feedback, right? So having that composable system with different knobs to turn and different components improve, plus a feedback loop where you can take errors that you encounter or synthetic data, and then most importantly, having that eval system to be able to benchmark your results. If you put those three together, that's what I'm calling self-improving RAG. It's a continuous system for self-improvement of your RAG pipeline. So, LandCB is, you probably know, LandCB is a vector database, but my counsel for people starting with RAG is don't actually start with vector search. Start with your BM25 as the benchmark, as the baseline. In some data sets, in a lot of data sets actually, full text search can work just as good, if not better. And it's less expensive to compute and index. So I would definitely start there. In this screenshot, you can see us using Llama Index with the Llama 2 paper data set. And we benchmarked using different retrieval techniques. And you can see that the FTS here, full text search, actually does better than vector search. I'm kind of making spoilers on re-ranking and hybrid, but you'll see a little bit more in this presentation. So the second knob you can turn is the chunking strategy. So depending on your use case, depending on the type of data, there's lots of different ways you can divide up your text data. And you want to do it in a way such that it matches with your use case so that you don't end up with a like garbage in, garbage out kind of pipeline. So for example, if you have text, right, versus JSON or HTML data, or if you're ingesting Markdown versus code, those all have different structures. They have different syntactic rules. You want to make sure that you use the correct parser and chunker for those. And for each of those, there are tons of details that you can tune, like the window size, amount of overlap, the list of delimiters that you can give it, things like, and then you have to be aware of things like the token limit, so that your context doesn't actually fits both your LLM and your embedding model. Right? There's LangChain. Fortunately, LangChain and Llama Index comes with tons of chunking processors, and so I have a link, but given that the internet's not really working, so we have a blog post as a survey on all of these different techniques. So I'll post the slides afterwards, so you can kind of get a sense for what they are. Right, and of course, good evals here makes this experimentation process a lot faster. And then lastly is just be careful of the money that you're spending on the embedding API. If you're using OpenAI or something like that, make sure you, let's say, like sample the data, so that you're not each experiment is not like a billion embeddings or something like that. Okay. Come on. Okay. A second big knob you can turn, of course, is the embedding model, right? And how to choose the right one is very important. So, in my experience, it's almost always easiest to just start with the MTB leaderboard, and I couldn't get Hugging Face to load, but let me see if I loaded. Hugging Face looks like this right now, but. I got something to load on GitHub, I guess, or maybe a refresh. But anyways, how many of you know what the MTEB leaderboard is? Okay, right. So MTEB stands for Massive Text Embedding Benchmark, and essentially it's a large-scale benchmark that you can run. And the easiest way to look at the results is on Hugging Face. It's a maintained list of all the different embedding models and how they perform for different problems. And so you can just go there and take a look at the top ones, and you can essentially choose, like, most people I think would probably start with like OpenAI, and if you want something that runs locally, or you don't want to pay that OpenAI cost but you have local infrastructure, you can always start with something from Hugging Face. And then, if you really need sort of the best quality for your problem, take a look at the different metrics that they have, right? And that brings us to selecting a good metric. So NDCG is usually a pretty good default for ranking problems, and this is where a lot of people start. So NDCG is great for ranking problems, and it's been very useful for recommender systems, and no surprise, pretty useful for measuring embedding models as well. And of course, if you are working under certain constraints, like pay attention to the token limit of the model, number of dimensions of the output of the vectors, and then the inference cost of itself, right? So you take in all of that into account, and basically what that helps you do is choose the lightest model that will satisfy the task at hand. And most of the time, you actually don't need sort of the absolute highest in the MTB leaderboard, but it's more about choosing the one that's just good enough for the tasks. And how many of you have tried the latest OpenAI embedding models, like text embedding 3 large? And have you guys tried the dimension reduction functionality there? Do you guys know about the functionality? So when you generate the embeddings in the new OpenAI embeddings API, you can actually tell it, I only want a certain number of dimensions back. And so we don't know exactly what it does, but I think the best guess is basically just chopping off the first n dimensions that you give it. And And again, let me see. Yeah. So we did some benchmarks, and if you comparing just the ones across OpenAI, so on the left you see Ada 2, and then text embedding 3 small and large, and then reduced to 1024, 512, and 256 dimensions. So no surprise that as you reduce the dimensions for the same model, the quality goes down slightly. But what is surprising is actually, like, if you take text embedding 3 large and you reduce that to 256 dimensions, that actually performs better in our benchmark than like Ada 2, which is 1536 dimensions, and 256 is much easier to store, index, and it's much faster to query as well. So I think the biggest gains with embeddings is not just like picking the best model out of the gate, but actually fine-tuning it and continuously improving it over time. So especially if your domain knowledge is a little bit different from the training data that went into the embedding model, or if your distributions end up being different, then fine-tuning can be a good way to make significant improvements. And you don't really need a ton of data. As you know, this LandCB user tweeted with Chris generated about $10 worth of synthetic data using OpenAI, and was able to take a much smaller open source model and essentially make that perform much better for his use case than sort of the biggest and best generic embedding models. Right, and so, of course, selecting the right samples and labels matter here. And so just like if you worked in personalization and recommendation, a lot of the labels will come in and you have basically positive labels. It's much harder to generate negative samples, and you have to be a little bit careful about what to label and exactly what to feed that model. And if you don't have, when we start putting that into production, we don't have user data to start with. And if you need an initial boost in quality, synthetic data is often always a great way to start. And so sort of a simplified loop here is I'm showing it here. I'm just looking at the time here. So you can essentially set up this pipeline where you can figure out the right chunking strategy and then figure out the right embedding model. And then once you have user feedback or you have synthetic data, that's where fine-tuning can happen. And this is what completes this feedback loop. So if you know how well your system is doing with good evals, and you have a good system to essentially collect user feedback and run the fine-tuning, you can then have a pretty basic feedback loop that will continuously improve your RAG pipeline over time. So the second part is let's talk about a little bit more advanced loop of, okay, first I started with BM25 benchmarks, baselines, and then I moved on to vector search, but I can actually combine the two. Oftentimes, even if one is better than the other, it doesn't mean one strictly dominates the other in all samples and all queries, right? So they're typically good for different use cases, and you can add more things on top of that to create hybrid search with multiple recallers. Again, this is very similar if you've worked in recommender systems. So you can certainly filter the search before you get into that. BM25, and recently there's been more research into graph RAG and using graph databases for retrieving more complicated and sophisticated relationships. Right, so filters, if you have explicit structure, right, use it if you can. Keywords and fuzzy search, BM25 is really good at that. And then, of course, like vectors captures these semantic relationships. For example, if you search for person, BM25 is really good at returning everything related to person, person's persona, or whatever, but it won't return things like customer, user, and things that have sort of semantically similar meanings to the search term. And of course, if you have a pretty deep and explicit knowledge graph databases might be a good choice here to add to it as well. So of course, if you have multiple recallers, that means you have multiple sets of results. but you can only present one to the user, or you give one to the LLM. So how do you sort the combined results? So you want to make decisions on whether you use the ranks of the results or a score. And then the scores that come out of each recaller might not be comparable. So you need to think about calibration, normalization. And then once you combine them, you need to think about picking the right re-ranker and then improving that re-ranker over time. So in our experiments, the Cohere re-ranker via the API tend to perform the best. And then just a simple linear combination added gains and was the cheapest and easiest to do. And then there was a gamut of open source models that you can use for re-ranking. And you can actually even prompt OpenAI into becoming, or ChatGPT into becoming a re-ranker model for you. So if you put all that together, this is the whole system, which I'm calling the context engine because it's way more than just a vector database that you can tune using the feedback that you get from the user. Essentially, this automation becomes, okay, have a way to measure your progress and measure the quality of your results. That feedback loop where the user responses are being used to turn the right knobs in the systems. And that gives us the way to, say, continually self-optimize your RAG pipeline. Now, of course, these things won't be 100% automated, so don't expect that to be the case. It wasn't the case for recommender systems, and it won't be the case for RAG. So what's important is look at the metrics. You need to have visualization tooling, and then you need to pay particular attention to edge cases. So my expectation here is just like in recommender systems, you'll have a really big step function in quality as when you first start putting these fine-tuning processes and self-optimization processes in place, and then it'll taper off and become sort of a long-tail problem. LandCB, I would call us the all-in-one database for AI. So the context engine have different ways to query your data. You can store different data, and if you went to Jerry's talk, right, in addition to the vectors, you also need a way to store like the source documents or the source images if it's multimodal, and the metadata that you can query as well. So LandCB is an embedded open source database. It's very flexible with storage options, so you can actually store your data and vectors directly in S3 and query it from your application or query it from like a Lambda function. And LandCB is multimodal, so you can store multimodal data. You can run multimodal workloads from vector search to full text search to SQL. And the use case is multimodal, so from search to analytics to fine-tuning and training. You can use LandCB for all of those. And there's an embedding registry, so we can essentially automate the embedding generation process. You can specify the embedding model that you want to use and have embedding generation be automatically taken care of by LandCB. All right, and then I think I'm coming up on time, so I'm going to skip some of these slides. But essentially what LandCB gives you is the ability to have a single table that can run all the different workloads that you need and house all the different data that you need for AI in general. From just SQL and analytics that you see on the left, PyTorch training and fine-tuning in the middle, and search from vectors or full-text search indices on the right. So thanks for listening to my talk. On the left, you'll see the Discord for LandCB community, so please join us and check us out on GitHub.
Awesome. Thank you so much, Chang. We do have time for a couple of questions, if that's okay. And then is Felix in the room? Okay, you're up next, so we're going to. Who has a question?
Thank you, very exciting. One question, how do you formulate user feedback so that the models can actually learn? Is there like a particular format? Is there like some impedance mismatch? Because many times these signals can be noisy. How do you clean them up before you push them to the system, or is it like case by case?
Yeah, it's hard. It's a little bit hard to standardize, But typically, yeah, you definitely want to clean up the data. Um, but typically, easiest would be like if you have answers that you presented to the prompt, and then you have some user action that was like rejected or accepted, and then you can also use things like if they're like subjective evals or something like that with human labeling, that can also serve as good data for fine tuning. And then the synthetic data, for example, like if you're doing search, if you have like a product description or something like that, you can essentially tell ChatGPT like what would be a good use query that generates or that would result in this product description or be similar to this one. So it's not really standard, unfortunately.